Good afternoon, everybody. Welcome to the Nest.js Twitch channel. My name is Adam, and today we'll be continuing. Okay, start that again. Good afternoon, everybody. Welcome to the Nest.js Twitch channel. My name is Adam. Today, I'm going to be continuing on the stream I did last week. So last week we were looking through how to build a modern web application with Neo4j and TypeScript. I'm going to continue on along those lines today. For anybody watching on the on catch up, watching on YouTube, then everything is available on the repository. So if you are watching, the code should be up there now. If you have any comments, any suggestions, or any feature requests, then feel free to let me know. So the biggest piece of news that we have coming on from last week is this poll is now finished. So I was looking for. Sorry. Bear with me while I just fix the problem with the sound. Okay, let's try that again. So does that sound any better? Can somebody let me know in the chat whether that's better? Okay, sounds good. Cool. So let's start that one again. So yeah, the great thing about streaming things live. But yeah, so welcome everybody to the Neo4j Twitch channel. Like I say, my name is Adam, and I'm part of the developer relations team at Neo4j. So in the past few weeks, I've been looking at building a modern application with Neo4j and TypeScript. So today I'm going to be continuing along those lines. So the biggest piece of news to come from last week is that this poll is now finished. The poll was running last week during the session, and essentially I wanted to know what you'd like to see from the project. So the results are in, and a subscription / software as a service site won. So today I'm going to introduce you to the client that we're going to be working for now. So based on the feedback, I wanted to find something that would help to show off the features of Neo4j, but also to demonstrate how to build an application. So what we've gone for is a client, and our client is Neoflix. So Neoflix is a video streaming service that allows users to buy monthly subscriptions for films and TV shows. And then those users can purchase many packages, which provide access to curated lists of content. And then all of the content that is provided by Neoflix is categorized by type, by language, and by genre as well. Cool. And the reason that Neoflix are interested in Neo4j, the name is purely just a coincidence, but they like to migrate their application over to Neo4j from another provider to allow them to provide better real-time recommendations. So one thing we'll do a little bit further on in the series is to look at real-time recommendations and how we can improve what they have at the moment. So this week, I'm going to be looking at the data model. We'll look at how we can derive the data model. I found some data that we can use on the internet for this project, and we'll look at importing the data in today. And if we have any time, we'll also create some basic REST controllers in Next.js. Cool. So my favorite video on the subject of all time is a video from back in 2017, Graph Connect Europe in London. Back from a time where we could be in the same room as each other and speak to each other. This great talk, which I think was a few after to one I did on that morning, by Don Davis, basically goes through the ways that you can decipher your graph model and turn basic language into Neo4j essentially. Cool. But yeah, I guess one of the approaches, and this is something that stuck with me for a long time. One of the approaches that I found the most simplest and the best way to get going is to essentially do what this talk tells you to do, and is to extract the nouns and verbs from a problem statement or from user stories, and then use those to influence the model. The main benefit for that is that you're using what's called like ubiquitous language, so the same language that the company is using, the same language as the domain. So there's no chance of introducing anything called tribal knowledge. So we can identify the nodes from this problem statement by identifying the nouns. So I've highlighted the nouns here in blue. So Neoflix is a video streaming service. So it's offering videos, which allows users. So that'll be what we would call the people that use the site. Those users will buy subscriptions for films and TV shows. So the different content that we offer can be categorized in different ways. So these may turn into sublabels of a video label. And then those users can purchase many packages that provide access to create a list of content. All that content is then categorized by a type and then by the language and genre as well. So what we can do is we can extract this out into nodes, and then we can draw the relationships between them. The way we identify the relationships is to identify the verbs in the sentence. So we don't have too many here at the moment, but we can see that a user will buy a monthly subscription. So I've got purchase there in green as well. So I guess this depends on the domain and what the business feel more comfortable with. But yeah, we can choose one of those terms, and I think I'll probably go with purchase in this case. So they purchase a package which then provides access to content. So there will be a relationship between the package and the pieces of content. We can call that provides access. And then all of that content is categorized by type, language, and genre as well. So we can take the categorized to create a relationship type. Cool. So in terms of importing the data, so let's come back into the real world for a moment. So we're going to use a test data set for this. And this is the best data set that I found on Kaggle. So it's a data set from 3 years ago, but it's still perfectly good to use. So it's the Movies Dataset. So if we take a look at this, we'll see the different files in there. So the main one is the movies metadata. So this is a huge file. So it's got, I can't see how many it's got in there. But yeah, so it's got certain information about the movies in there. So for example, we have the the title of the movie. We have the original title, things like that. So this isn't showing me too much information. So what we can do instead is we can look at this in Neo4j instead. So the way we're going to import this data, because it's CSV data, is we're going to use load CSV. So a load CSV statement looks a bit like this. So we would use the load CSV command to load the data into Neo4j using Cypher. And then we're saying that we're loading the CSV with headers because the first line of the file is headers. And we say from, and we're going to take a local file of movies.csv. We give that an alias of row, and then once we've done that, we can then run a Cypher statement to load the data in. So if I go to localhost 7474 to open up the browser. So I've already imported this data in. So the entire data set has 710,000 nodes and almost 13 million relationships there. So it's a big data set. So it takes a few minutes to import. So I'm not going to go through the process again, but I'll show you, walk you through the queries that I use to import the data in. But if we take a look, for example, at the movies dataset, so in order to import this data in, the first thing I need to do is to change some sort of configuration inside Neo4j. So there's two ways that you can look at importing the data in. So I've already created my my database. If I can find it, it should be the active one. I think it might be. Okay, cool. So there's two ways that we can go about this. So I've downloaded the files and unzip the files. So I've now got them all in this CSV format. So there's two ways that I can import the data into Neo4j using load CSV. So I can either move the data into the import folder, which I have already done. So if we go into the actual Neo4j home folder, so you'll know Neo4j home because it's got the bin folder which has Neo4j inside there, Neo4j admin. So what we can do is we can paste these files into this import directory, or what we could do instead is we could take the path name and then update the import setting to that folder, and then that would mean that we can access that the information from that folder. So once we do that, we apply and then restart the database. Then the files will be available. So that's just a security feature in Neo4j. So I have these files in my import folder already. So what I can do is I can then run the load CSV file, and then I can look at the data that's inside there. So I'd say, for example, load CSV with headers from file : / and then it's movies _ metadata CSV as row. And then if I say return count style, we'll be able to see how many rows there are inside that database, inside that CSV file. So we've got 45,463 movies inside there, or lines. There may be some duplicates inside there as well. So if I return the row and then limit 1, I can see the kind of data that's held inside there. So we can see that, for example, we have the title there. So this movie there is Toy Story. We've got things like an overview, and we've got things like the runtime, the videos, whether it is a video or not, some things like the production company as well. So this is kind of a strange data set, so we're going to need to do some manipulation inside there. So to do that, we can use APOC or native Cypher. So by default, when you load things into Neo4j using load CSV, everything is cast as a string by default. So you'll have to cast things in into their rightful format. So for example, we have this runtime. So this is a string, 81.0. So what we would need to do is use the toFloat function to convert that. And for example, the revenue, we can convert that into an integer. The release date, we can use the datetime function to convert that into a Neo4j datetime, or we can just use a date because we've got no time there. And then there are some strange things inside here which are actually turn out to be JSON objects inside of a CSV, which is the first time I've seen this. But what we can do is we can use a function inside load CSV to convert that. So for example, if I take this this value here, and if I look in the APOC help, and then we look for convert, if we just search for JSON, we should be able to find it. So this will give me all of the procedures and functions that use JSON. We'll have JSON inside the name, and what we're looking for is to convert. So the two things that we can interchange between is the from JSON list and from JSON map, and it really just depends on the data type. So in this case, we have a JSON map, so we have like an array. And this is a function, so instead of using core, I just use a return, say apoc.convert from JSON list. And then return that. So that's turned that into an object or a map, which the term is cipher map inside. Well, the term is map inside cipher. So that will give us a cipher map, and then we can use that to then manipulate the data, and then we can create nodes and relationships off of there. So if I take the query that I loaded a little bit later on, if we take the query that I loaded earlier on, then it's quite a long query, so we'll unpack it. But essentially, this is taking the movies metadata file and then assigning every line in that to be a row, and then I'm using a periodic commit. So what this will do is it will go through the CSV file. It will process 1,000 rows at a time, and then commit the data at every 1,000th row. So the first thing I do is I use the ID property on the row to create a movie. So I need, again, that's a string, so I need to cast that into an integer. And then I need to do some sort of mass assignment. So every time a node is found in the database with that ID, what I'll do is I will set these properties. So I can use this map projection to take some information from row. So for example, everything inside here that has a dot next to it is assigned directly from the row, so row.overview. So it's kind of a shorthand of saying overview is row.overview. So it's a good way to be lazy and to cut down the amount of things we're typing. So I can take all the strings straight through, and I can assign those. So for the things that need to be converted into a certain format, so for example, the runtime, I convert that to a float using the toFloat function. And then the release date, I then convert that into a date, the revenue to a float, etc. So that will create me my basic movie nodes. And then I can use the rest of the data inside the CSV file to create the relationships and to create the structure. So what you see here is a what's called the for each hack in the Neo4j terms. So in Neo4j we don't have a concept of an if statement. So instead, what we do is we create an array which has either one value or zero values, depending on some sort of predicate. So, for example, the original language on the object can either be a two-letter reference to a language, or it can be null. So if you try to merge something based on a null value, then you'll get an error inside Neo4j, because Neo4j rightly doesn't allow you to do that. So what I say is for each any value, so we're not going to use this value, so I just called it an underscore. In the values returned from this case statement. So if the row dot original language is not null, then I return an array with one item in there, and that could be, again, that could be anything. I use a one, otherwise it would be an empty array. And then we pipe the value into this inner array here. So if the original language is not null, then it will run this command once. And if it's null, then it will get an empty array, and this little block won't be run. So I merge a language based on the original language value inside the row, and then create a relationship to say that merge that M is a original language of L. And again, so the for each hack again, in order to set an additional label on there. So if the row.video column is true, then I set a new label on that movie node of video, and the same for adult as well. So for the spoken languages, which is a JSON list, what I do is I use the APOC convert from JSON list to turn that into a cipher list, iterate over that, each of the values inside there, merge a language based on the ID property, which is equal to the ISO 6391. And then if I'm just creating that language for the first time, then I also set the name, otherwise I ignore the values, and then merge the relationship of spoken in language between the two. So I do that for everything inside the CSV file. So I've already uploaded to the Twitch projects inside the docs. There is a document on modeling. So this basically goes through the things I've explained so far. So if you are unsure of anything that I've said so far, then this is a good place to look. But essentially, I go through explaining what the nouns are, the verbs, how to extract those and put them into a model, and then talk about deriving the properties. So I go through for each of the CSV files. I take a look at the files and then work out what is used, how it's used, and where it should sit. So I take, for example, the properties and then set them, cast them if necessary to something other than a string. The additional labels, so the video and adult, so those are either true or false with a capital for the first letter. So, for example, the video, we set the video label. And for the adult, maybe it's something that we'd use to exclude from certain packages. Maybe if a user account has a individual profile, which is a child's profile, then we should look to exclude that as well. And then we look at the relationship types that are created from there. For the credits.csv file, so basically that is it holds an ID, which is the movie ID cast as a string. And then it has objects for cast and for crew. So these are both JSON lists. So essentially for the cast, Each of the values looks a little bit like this. So we have information about a person. So for example, the name and the ID. So the ID is a unique identifier for that person. And then the name is a string. There's also a profile path, which relates to an image somewhere. So we'd stored that data in there. And then gender, which is like an encoded value. So it looks like some sort of foreign key from the original data set. So to me, it looks like 0 is unknown, 1 is male and 2 is female. So we can then cast that, or we can use that value later on to set labels of male and female if we ever do need to search on that data. And then for the casting information, so we would use this information to create the person and then create the cast for relationship between the person and the movie. So in this case, it's got properties for the cast ID, which is an integer, the credit ID, which is a string, and then character, which is a string. So if we take a look at this value here, so we've got Tom Hanks, which is has a gender here of maybe got that number wrong, but a gender of 2. And Tom Hanks played Woody inside Toy Story. So the ID for this row, so 862 must be Toy Story there. For the crew, it's a very similar thing. So we've got the credit ID. There's no cast ID in there, but we have the ID, the gender, and the name of the person, and the profile path. And then we have the department and the job that the person did inside that department. So if I show you the query for that one, so I'm using product commit 1000 again, so it'll commit every 1000 rows. So I cycle through the file. So I've already created the movies, so I can use a match query rather than a merge, and it will look up this movie based on its ID, and then it will convert the cast into a list from a JSON list, merge the person based on the ID from that cast value, and then if I'm creating the person for the first time, then set the name property to cast.name, the gender property to cast.gender, and the profile path to cast.profile path. Merge a relationship between the person and the movie. And then if I'm creating that for the first time, then I can use a mass assignment to basically take the credit ID, the cast ID, the character, and the order to save that. Same thing for crew. So I convert the JSON list and then assign that to crew, and then create the person, and then set the properties if necessary. Merge the relationship between the two, and then set the properties on the relationship. For the keyword, so there is a ID for each row inside the keywords, and there's also keywords, which is basically a string which represents a JSON array. So each one of the items in those array has an ID and a name. So in that case, what we can do is we can create the keywords. And then merge the relationship between the two. Same deal for the ratings. So inside each of the ratings, we have a movie ID, we have a user ID, we have a timestamp, which is the second since epoch, and the rating, which looks like a float. So we can use this to create a relationship between a user and a movie. So there's no user information at the moment, so we might have to fake that or mock that a little bit further on down the line. But essentially, right now, it doesn't really matter what that user is, who that user is, or what they're doing. Cool. And then the first thing that we should do, because this is a large data set, so I think in the grand scheme of things, it's not huge, but it's more than 170 nodes, which is the basic movies example. So what we should be doing is creating the unique constraints, unique identifiers for the nodes and relationships. So on this database, I've created constraints for everything. So every item has an ID property, which is unique. So these are only things that we'll be searching on at the moment. So they're only things I've created constraints for. There may be an instance further on down the line. Maybe we'll create an API where a user can search. In which case, we'll probably want to index people and movies, the titles and the names to allow people to search. But for now, we don't need to worry too much about that. The reason that we should do this is because, for example, we are merging on merging or matching on an ID property. By creating the constraint, essentially what we do is we use a unique index seek in this case to find the keyword or to find the node. Whereas otherwise we'd have to go through every single keyword in order to find the node that we're looking for. If we've only got a couple of hundred keywords, it's not going to be too much of a problem. But if you're inserting, for example, over 1 million users, which I think is what we have inside here, then it's going to slow down because every time you're searching for every single node, you're adding another node to the list. Cool. So with all of those queries run, then we will get a schema that looks a little bit like this. So we have a movie which has sublabels of adult and video, so we can just hide those for now just to make things clearer. And then this is the data that we now have in the database. So we have a movie. That movie is possibly part of a collection. So you think that Toy Story is part of the Toy Story collection. It is in a genre or one or more genres. A person can be either a crew for a movie or cast in the movie, so cast for movie. The movie has an original language or a spoken language to language node. It was produced within a country and is also assigned to keywords as well. So if we say, for example, match M movie in genre G, return everything limit 10. So we can see, for example, the Scarlet Empress is in the genres of history, romance, and drama. Suspect is a thriller and a drama and a crime as well. Throw Mama Off the Train is a crime comedy. And Semi-Tough is a comedy, drama, romance. Cool, so that's the data model inside there. So we can see as well inside the database that, for example, a movie has many actors, so the pink nodes here are people. It has keywords, so ex-wife, mother, murderer, and train. I'm not quite sure where they've come from. Maybe there's some processing on the overview to find that data out. We don't need to worry too much about that at the moment. And if we take a person, so for example, Oprah Winfrey, and then check out what else she's been in. There are many films there as well. Cool. So one of the examples that we have in the movies data set is to find people who have been in a movie with Tom Hanks. So we can do that again with this data set. So we can find the Sorry, we want to find the person who's in the cast for a movie where p.name equals Tom Hanks. And then we want to find other cast members. And then if we return the person in the movie and then the second person. So inside the money pit, then we have all of these actors here. And if I increase the limit there a little bit more, we should be able to see a few more movies. Of course, we have the Lady Killer, we have Punchline, we have Dragnet, the Da Vinci Code, and the Money. That's cool, and we can do the degrees of Kevin Bacon as well, but I won't go too much into detail about that one. Cool. So one thing that did change from last week is something that I put into the documentation. Is I created some dynamic configuration now for Nest JS. So previously the configuration was all held in static variables or constants inside the instantiation of the app. So it's kind of bad practice to do that. It becomes difficult to manage those environment variables when you go into test in production. So a better practice is to use some sort of config library. So on other projects, I've used .env. Inside Nest.js, there's this package called Nest JS config. And what this does is it provides a config module and a config service for you. From that, it will load up the values that are inside a .env file, and it will use those inside the configuration. So there's a few things to do to change the configuration. So the first thing to do is to run npm install and then nest.js and config. So then that will give you a config module that you can then register with its for root method. So to register it, we can just run that. And then what I did is I took the values from the app module and then put them into .env. So using the screaming snake case as the naming convention. So we've got the scheme there. We've got localhost, username and password, and then the port. So once you've used registered the config model, this then provides a config service. And on there's a get method which allows you to get in the configuration. So for example, if I use the injected config service to get the Neo4j username, that'll give me Neo. So it'll read that Neo4j username value from the .env. If I jump into the module, so I created another for root async value, and essentially what I needed to do was to be able to provide the user with the ability to provide a factory function to create that config. So the config is built up in the same way. So we're providing something with Neo4j config. So what I've done is I've used the spread operator, and then for this I couldn't assign this to anything, and then still use the spread operator. But essentially what this means is that anything passed in as the config provider I could then use it as the Neo4j config. So as long as that provides a Neo4j config object, as this function does here above, then I'll be able to then bring that into the driver function, and then to inject that into the services. So then the configuration of the app module changed a little bit. So I was using this Neo4 root async function, passing in this what would be this provider. So I'm importing in the config module into this dynamic module, which has been registered up here. That will then allow me to inject the config service, and then I use a factory function to pull the relevant keys from the database. So then if I run start in dev mode, then so it's working exactly the same way. So it still gives me the same results there, but now I've got 710,000 nodes. And it just means that I can then create, for example, a .m file or a .m.test file, and then it means I can just inject the variables in. So for example, if I was using AWS, I would use their environment variable store to store that information. Cool. So this application is now talking to a database which again has 710,000 nodes inside there. So if we, for example, take a look at a competitor of Neoflix, so then we can see some of the pieces of functionality that we may need from a site. So for example, when you log on to the site, you've got some recommendations here. So these are some things that I've been watching recently, some things I've added to my list. Things I've watched already that I may want to watch again, which I think is a strange thing to have in the recommendations, but there we are. Or we can browse by these different types. We can browse by the type of content, and then once we get into the type of content, we can then explore the different genres in there. So there's a few things that I think we will need. So what I'll do is I'll create inside the repository a new file, and we'll call it todo.md, and I'll start to write some features in here. So for example, we need to browse by category, browse by type, etc., etc. Cool. So in order to do this, we'll need to update our controllers, or to create some new controllers, and then we can use services which then use the Neo4j service themselves to pull data in. So just like we did last week, I can use the Nest CLI to start to generate new pieces of functionality, new pieces of code. One of the key pieces of terminology that we've used inside here so far is films and TV shows, but they all come under the umbrella of content. It makes sense to use that terminology. What we can do is we can create a new module for content, and we can encapsulate all of that functionality inside that content module. So if I run Nest generate module and call it content, So this will go away and edit files for me and create this this content module. Which is great. I also want to generate a service. Content service. And then at some point as well, I also want a controller. That compiles fine, perfect. Cool, so we have this this content module. So inside this, what we want to do is we want to basically take an instance of the Neo4j module, register it inside this module. So then the content service will have access to that. Then inside the content service, what we want to do is create some methods that then call Neo4j in order to pull things in. So if we take a look at our database, so for example, we want to get a list of movies, and we want to just display some basic information about them. So if I go into the content controller and create a new method, so this will be a get method. We'll call that get index. Cool. So now if we go to get index, then we should have we should see hello world. Cool. So if I go to localhost 3000 and then content, we currently have a 404. So what we need to do is we need to register the content module inside the app module. So this is a static module. There's no no configuration there. So if I add the content module, sorry. Much better. Cool. Hit refresh there. So I've got hello world, which is great. So basically, inside this this API endpoint, what we want to do is just to create a simple function that just returns a list of movies. So inside the constructor here, so what we want to do is we want to inject the content service. Cool. Inside here, so we want, for example, get movies. This itself should use the Neo4j service. Cool. So this will give me the same error like that last week. So Nest can't resolve the dependencies for the content service. So make sure that the Neo4j service is available. Because the Neo4j module isn't a global module, I need to include it in here. So this will need to import